Very briefly, we're going to look at convection current. And so as I mentioned in the previous video, this is when we have current that's flowing through some insulating medium. And so what this means is that this current is not going to satisfy Ohm's law. So does not satisfy Ohm's law. And so an example of this would be, for instance, an electron beam in a vacuum. So E beam in a vacuum. And so you might be asking yourself, well, if we can't use Ohm's law, how are we going to even talk about current? And so it turns out that we can go back to sort of a more general equation. So we can say in general for our convection current, and we're going to see this is going to apply to conduction current as well, but we can think of this as sort of an even more general case than Ohm's law. So we can say in general for our convection current density, we have that it's equal to, so J is equal to rho V times U. And so let me define what these two things are. So our rho V here is going to be the volume density of the flowing charge. So volume density of flowing charge. So in our electron beam example, so this electron beam in a vacuum, how many electrons do we have per cubic centimeter, for instance, in that beam? And then we also need to multiply that by this U term, and this U is just going to be the velocity of the charge. And so this makes sense if we go back to our very basic definition of current, right? We're looking at how much charge passes a point in a given amount of time. And really the only difference here is that we're looking at current density, so we have this per meter squared. And so we can think about this dimensionally as well. We know that our current density should come out to be amps per square meter. So we know that dimensionally this is equal to some volume charge density. So that's going to have units of coulombs per cubic meter. And then that's multiplied by a velocity, which is of course meters per second. So we see the meters is canceling out with one of these meters. We have coulombs per second, which is by definition amps, divided by meters squared. And we see we have the desired dimensions for our current density.